I have it. I can, for this one, I can just read it to you. Another one, you might need to go to it.
Okay.
So for this one, it's y equals x squared ln natural.
Oh, natural log, yes.
Yeah. 4x. And we have to differentiate and then differentiate again. And I thought I differentiated.
So we want y prime and we also want y double prime?
Yeah.
Perfect.
But it was marking my y prime on, so.
Okay, so let's work on this. So first of all, y prime, since it's a product rule, we need the first function prime, which is 2x, times the second one, plus the first one, times the second one prime, which is 1 over 4x times the inner function prime. I simplified the 4 and I simplify 1x. So then y prime simplified is this for now. Is this okay so far?
Yeah, I found my error.
I love it. But since we're here, do you want to continue or you don't want to continue?
That's fine.
To continue?
Yes.
Okay. So for y double prime, the first function prime, I like to, since it's plus, it's okay. First function prime is 2 times natural log 4x plus 2x times 1 over 4x times the inner function prime plus 1. I simplify the 4. I simplify the x. 2 plus 1 will be 3. So then the second derivative is 2 natural log 4x plus 3. A lot of shadows here, but I'm afraid that if I push this, okay. Oh,
it's fine on my end.
Okay.
Um,
Perfect question. Anyone has questions on this? Anyone? Okay. Yes, Amanda, go ahead.
Did anybody have a different? I don't want to take up all the time if somebody has a different.
So, yes, go ahead. Evelyn, Aaron, Landon, Talea. Yes.
I had some for like 3.9 with the new rates.
Yes. So let's finish with this before we get to 3.9. Is that okay?
Yeah.
Very good. So don't forget to ask. Yes. Amanda?
So this one you might have to go to.
Okay.
It's for 3.7, and I don't know if I'm just entering it wrong. But for question 1, it's the last part, part H. So I'm getting the rest of it correct, and then it's just asking when is the particle speeding up, and then when is it slowing down.
Which problem are we looking at?
Number 1.
Number 1.
Well, 1 and 2. But both are asking the same thing for part H.
Okay, so why don't you give me, so see, when I open, it gives me this. But I don't know if this is your function. Is this your function?
I think so. So I had.
Okay, then. Perfect.
If not, it's very similar.
So can you verify your function? Is it, do you have t to the third?
Yep.
Minus 9t squared and plus 24t?
Yes.
Okay. You have the same thing, right? Okay, perfect. So we are only looking at spinning up or slowing down, correct? Is that all we needed? Okay.
Yeah, the rest of it, yeah, A through G is fine.
So like we did last time, I have to find the velocity, which is 3t squared minus 18t plus 24. I factor out the 3, and I get t squared minus 6t plus 8. So this is 3t minus 2. It appears like it's like the same function we worked on in class. Maybe not. I'm just taking my memory. When you get to my age, you will always want to check your memory. I could be wrong. It's exactly the same function.
Oh yeah, it is the same. Total distance.
So
And we didn't look at right at rest. We did, yeah, the velocity, all that at rest.
So the speeding up and the slowing down is right here in the table. You have to study the sign of the velocity, the acceleration, and then conclusion.
Mm-hmm. So speeding up from 0 to 2. No, slow down.
They're going opposite directions.
Mhm. So slowing down. So it's speeding up at between 2 and 3, and then 4 and 6.
So that's why I'm begging my students to do the problems that we do in class first, because you get so much information and confidence.
I think it might have been the way I was entering it, 'cause it
I'm
was
not
asking
sure.
for.
So do you need anything else on this one?
No, that's good.
Okay.
Sorry.
No worries, no worries. Do you have other questions?
It was one more, but it was on 3.9, and you said to hold on 3.9.
No, right now. So let Aaron start his problem, and then we'll move on to 3.9. Although, remember 3.9, we only had a couple of, maybe 2 or 3 problems. We still have to work on that. But if we pick problems or we work on the problems you encountered, it's the same thing to me. So, yes, Aaron, will you tell us which problem, or do we need to see it? Do you want to share your screen, or?
I just kind of figured out like just right now.
Okay.
It was just the one with like the cylinder and like the water increasing.
Okay.
Or something like that.
Okay. So back to you, Amanda.
Mine was, it gave an equation
Yes, I'm ready.
for 3.9, and it said y equals the square root of 2x plus 1. And then it said dx over dy, dx over dt equals 3, because it said x and y are both functions of t.
Functions of time. Yes.
Yeah. So it said dx over dt equals 3. Find dy
over dt.
over dt when x equals 4.
So remember this. This is the trap. We cannot look at that.
Mm-hmm.
We have to find dy over dt first, and then plug in whatever they tell us.
Mm-hmm.
So in order to differentiate this, y equals the square root of 2x plus 1. That's my page 2. Remember, these are both functions of time. So I differentiate the left and I differentiate the right. So I have to write dy over dt equals 1 over 2 the square root of 2x plus 1 times the inner function prime, which is 2, times x prime, which is a function of time, times dx over dt. I will simplify, and now I can plug in x equals 4. So I have dy over dt equals 1 over 4 times 2 is 8, 8 plus 1 is 9, the square root of 9 is 3, so it's 1/3, times dx over dt, which was given to us, which is 3, so nice, dy over dt when x is 4 is 1. Is this okay?
Yes, I was doing all that, and I'm not plugging in 3 at the end.
It's 4, and this is 3.
Oops. Yes.
Good. Anything else? Have you encountered other questions, other situations that we want to work on? I have here some scrap paper, and it doesn't connect well. Other questions from me? Would you like to work on anything else? Okay, so before I forget, because I don't remember if Evelyn was here when we said that, so we are extending the homework, the written homework, everything that was due today for Wednesday. If you already turn it in, you don't have to turn it again. If you want to turn it again, you can. Okay, So anyone else
Okay,
has, say it again?
No, I'm saying thank you.
Okay, perfect. So what am I doing? I am going back to the book. And where are you guys? Here you are. So I don't need this. Why I can't move it from here? Okay. And where is my book? Right here. And here's 3.9. So we're moving on and looking at other examples from 3.9. So let's look at number 14. If a snowball melts so that its surface area decreases at a rate of 1 centimeter square per minute, find the rate at which the diameter decreases when the diameter is 10. Is this of interest?
Yes, please, because something similar was in the assignment. Thank you.
Okay, so don't let me work on the problems that I assigned. What, did I assign 14?
No. It's similar, but it's not the exact thing.
Okay, so let's work on 14 then. So in the first sentence, if a snowball melts so that the its surface area decreases at a rate of 1 centimeter square per minute, decreases means negative 1 centimeter squared per minute. I have to identify what this is. A snowball melts so that its surface area decreases at a rate of 1 centimeter square per minute. I need to identify what this is. Anyone?
We need the formula for surface area.
No. First we identify, before we even look at the formula, we have to identify what is given. So I need to identify what this is, because I don't know what this is.
So in that d something over dt.
Exactly. It's a surface area, of course. It must be ds over dt. Awesome. Because it's centimeters squared, I know it has to be surface. If it's minutes, I need to know, of course, I know that that is the time. Awesome. Perfect. Now let's read on, and then we'll come back to formulas or anything else. Okay, so where are you guys? Okay, here you are. Share. Perfect. Good. So because it says decreases, I have to put a negative sign. Now, find the rate at which the diameter decreases when the diameter is 10 centimeters. Find the rate when the diameter is 10. So what is this? One more time. Find the rate at which the diameter decreases. So I'm expecting a negative number when the diameter is 10 centimeters. Again, I have to identify what this is. I don't want to use D for diameter because D is normally stands for the derivative. So I'm going to use W. So W is the diameter. So then what am I asked to find when W is 10 centimeters?
dW over dt.
Thank you. See, you understand there is a crash here. If I write dd, nobody, will understand what that means. Awesome. So we establish what is given. We establish what we're asked to determine. We use the specific letter for the diameter. And we have this. We know that that's the trap. Nobody cares about it till the last step. We put it in there, but we don't care for it till the very last step. Good. So now, let me just show you a few things. We know that the volume of a sphere is 4 pi over 3 r cubed. And you can say, wait a minute, what are you talking about here? I'm just connecting something so you remember the surface area of a sphere. When you differentiate this, you get 4 pi r squared. So I simply differentiated the volume to get the formula for the surface area. Volume. So in other words, if you remember the volume formula, you will never have to look up the surface area. Just differentiate, simplify, and you get 4 pi r squared. Of course, we don't need this in this problem, but the easiest thing to remember is the sphere, the volume of the sphere, 4 pi over 3 r cubed. You differentiate, and you always have the surface area. That's why I was connecting, although this is not necessary here. I wrote it so you always remember how to find the surface area. So you don't have to look it up. So obviously we have to start with that. Now, I do have a little bit of an issue here because they are talking about the diameter. I don't have the diameter here. I have the radius. But I know that the diameter equals what?
2 times the radius.
Yes, 2r. I'm going to replace r by w over 2 in the formula. So I have it ready. So s equals 4 pi times the radius squared, which is w squared over 4. I will simplify. So then s equals pi w squared. This is what I'm going to work with. I put a little dot underneath so I don't forget these two are functions of time. They're asking us the rate of change when blah, blah, blah. Well, I have to differentiate. Can anyone differentiate this equation for us?
2 pi w times 5. Oh, s prime over s. Wait. ds over dt.
Thank you. Good. On the other side, you already said 2 pi w times the inner function prime.
Just 1.
I put a dot underneath.
Oh, w and dw over dt.
Exactly. Exactly. Awesome. So then, this is what they want us to find. In order to find this, I will divide this by the whole thing. And let's see what happens. And that's page 3. So ds over dt equals, I'm going to copy it here, 2 pi w times dw over dt. So then dw over dt equals this over this. Do not separate this. This is one thing, one entity, over 2 pi w. And now, yes, fine, w equals 10. ds over dt is given to us as -1. So the top is -1. The denominator is 2 pi times 10. So we have -1 over 20 pi. And because they're expecting us to come up with a number, I don't know if they want an approximation or not, whatever. So I have 1 divided, careful, put parentheses, 20 times pi. So
I'm sorry, was the 10 given in the problem? The w equals 10, was that given in the word problem?
yeah, right here, w equals 10.
Got it, thank you.
Sure. So then we get approximately -0.0159. Measurement unit, please.
50 centimeters per second.
Yes, because it's a rate of change of distance with respect to time. Centimeter per minute. It was minute, right?
Mhm.
Yeah.
Yeah. And that's it. That's final. Any questions on this? Okay. Let's look at 17. Two cars start moving from the same point. One travels south, the other travels west. That's what I have so far. Good. One travels south at 60 miles an hour. And the other one travels west at 25. Good. I'm going to denote this by Y. I'm going to denote this by X. Can anyone tell us what is 25 miles per hour and what is 60 miles per hour? I have to identify what I'm given so that I can proceed. Without identifying what I'm given, I don't know how to proceed.
It's distance over time.
Yes, but I have to write it as a derivative.
Right, so we don't want to use D.
I have to use d, dx over dt. That is clear. I have to
just
use,
X. I meant instead of like D for distance, but just use X.
but I denoted this distance by x and this one by y.
Okay.
Good. And then, what does 60 mean, please? $60 miles per hour?
That's dy dt.
dy over dt. Awesome. Perfect.